Good afternoon, everyone. Alan Hoare here from TU Dublin and the Construction IT Alliance. I'm your chair for this afternoon. Welcome to the CitA Tech Trend 2021 series, and today we'll be focusing on a very topical issue, I suppose, in the sector, which is digital twins. I suppose some would suggest that perhaps there's a lot of hype around digital twins, but actually the reality is quite different. This is now quite a serious technological solution that clients, investors, developers are now getting quite excited about in both construction and property sectors. So I'd like to first of all thank our sponsors for this series, ARUP, Diatech, Murphy, RIB Software and Solibri. So if we could just have a quick look at our program, Shannon, thank you. The second slide, thank you. So we're joined by three speakers this afternoon. Simon Evans from ARUP, who's returning after he spoke. As you may remember, Simon spoke last year at the CitA Tech Live, and Simon is the digital energy leader at ARUP. Simon, you're very welcome. We also have Natalia Pinkovska who's the research manager at EVERCAM, and Natalia spoke recently about at the series, but today is more of a focus around fixed position cameras and full video, and how these can be a valuable input into digital twins. Natalia, you're very welcome. And last but not least, we have Isaac Putt from which is the UK and Ireland account manager for Solibri, who'll be talking about me and my ugly twin. I don't have any twin myself, but it'd be interesting to get an insight into that. So if you have any questions, ladies and gentlemen, you might pop them into the chat facility, and I'll keep an eye on that during the event. I suppose many would would know that digital twins is a replica of a physical twin, but how are digital twins accelerating and indeed automating traditional design, and production and operations? And how does it help in this propensity to look at an industrialized future for our sector? So Simon, you might take us through your presentation this afternoon. Thank you.
Brilliant, thanks Alan. Let me just bring my screen up. Hopefully that comes through. I'll open the chat window as well so I can respond to chats as they come. Great. Can you see my black screen? It should be.
It's the black screen, yes.
Perfect. Very good. And voila. Great. So thanks, Alan. And yeah, absolutely, as you were just framing then, digital twins are very high on the hype cycle, often perceived as a unicorn, this quite aspirational thing we're going to get to in the future at some point. And that's probably because of the heavy over promotion and inflated expectations that sometimes come with this concept. So I was lucky enough to speak at this event, or this series of events last year, and this time I'll be showing some of the updates on digital twins, particularly that we've seen over the last probably about 9-10 months or so, which have been quite radical. But as an introduction, so my name is Simon Evans, and I look after digital within our energy sectors here at ARUP, which means I look at how we can enhance and enable our design, delivery, and operations through the application of internet-era technologies. My background, so I'm a chartered mechanical engineer, a technology developer, and a fellow of the Institution of Mechanical Engineers, though my background particularly is in the energy sectors, namely oil and gas and offshore wind. Though, of course, I've got a particular passion for the applications of digital engineering into our sector and across the built environment more broadly, especially through adopting what we'll term a digital twin approach. And linked to that, the final part of my intro I'll say is that I work very closely with the National Digital Twin Programme, which is a programme being run at a national, but also collaborating internationally, which I'll talk about in a second as well. So the topic of today is digital twins. Are they unicorn or are they just misunderstood? So I'd like to start my presentation with this real quick slide. And it's a famous quote and I think quite an amazing photo from Henry Ford that says, if I'd asked people what they would have wanted, they would have said faster horses. Of course, that picture showing a car being towed by a horse. Now, why I think this is great and why I think this is really, really relevant when it comes to digital twins is the premise of all this is actually education, and how it's hard for many of us to conceptualize the art of the possible unless we're demonstrated it. And therefore, it's for us as industry and practitioners to help open and reveal behind the curtain, if you will, of some of the myths of what digital twins can or can't do. Well, it's hard not to get excited by this concept, of course, when you hear some statistics such as
Turn
this
it down
one.
a bit, will you?
Oh, sorry, Alan, I think you're on mute there, maybe would help. There you go. When you see statistics like this that came out the tail end of last year, that didn't necessarily take COVID into account, but show that the global digital twin market was valued about 3.1 billion last year, and is expected to reach nearly 50 billion in the next 3-4 years. Or a statistic that was way before COVID, back in 2017, that says half of all large companies will be using one, whatever one is, by 2021, resulting in a 10% improvement in effectiveness. Now, of course, I don't necessarily think this second statistic will come to pass, but what both of these really show is that however you consider this value has been determined or sliced up or calculated, they both point to this being a significant megatrend that's going to transcend all other trends that we've had to date. So let me dial back a bit and first introduce who ARUP are. So I know, looking at the call, I've got many of my colleagues here, which is great. But for those of you who aren't aware of ARUP, so ARUP are an engineering consultancy. We're known for working with and being involved in some of the world's most iconic projects, from things like the Sydney Opera House through to many others around the world. And we're quite uniquely completely employee owned, which means we're very purpose driven, and our mission is very much to shape a better world, which is not just a marketing tagline, it's actually core to how we operate and how we now see sustainable development as being everything. We've got about 14,000 employees working across pretty much every sector in 33 countries. But the key, not talking about ARUP, but going back to what digital twins are, is, well, what are they? And you'll hear from a couple of our speakers today, and I wanted to start some of this by framing what a digital twin is in its basic context. So in its basic terms, a digital twin is this. You've got some type of digital asset, then you have some type of physical asset, then you have some type of digital asset that is developed to a level of detail proportionate to what you're trying to achieve. By which I mean that this digital asset or digital clone, which we term a digital twin, could be some really detailed 3D model, if you will, with all the information attached, or it could simply be a 2D map or sketch or system, again, depending on what you're trying to do. Now, what we know is that there's data that flows from this physical state into this digital state through some type of pipeline or workflow. And this data is write time, not real time. And that's an important distinction, because nothing really ever needs to be real time unless you're doing, let's say, remote brain surgery from the other side of the world. It's all about being right time based on what you're trying to do and the questions you're trying to ask. And then when this information is in this digital state, you can, of course, derive insights, make decisions, and then importantly, allow interventions to be done back into the physical asset where your outcomes are delivered. Now, this connection, physical to digital, digital to physical, is what makes a twin, rather than, let's say, a model or a simulation. Now, of course, these are not new. The concept has been around for quite a while. And some of these earliest examples of digital twins was actually the Apollo 13 missions back in the 50s and 60s, where they used a concept at the time called digital mirroring to help bring the astronauts home safely. And since then, of course, we've had an explosion of the concept being used in the manufacturing and the aerospace sectors, probably for the last 20 or 30 years. And in the last maybe 10 years, the energy market, which is where I'm from, and particularly the last 3 years in the wider built environment. Now, the reason for this concept being really, really excitable and coming to light much more prevalently is that we've had an explosion in storage, compute, and connectivity. 3 factors, connectivity, of course, being things like the internet, but also more advanced and faster connectivity like 5G, that allows that circle of physical to digital, digital to physical, to be brought ever closer together. The other common misconception we hear when digital twins are talked about is this, that many think digital twins are here to replace BIM. BIM, of course, being building information modeling, but part of the generic or more broader category of information management. Now, what we know is that this is fundamentally not true. And the reason for that is that information management is a core component that you need in order for a digital twin to reach its full aspirations and full set of value. And that's why I think many of us and industry as a whole is starting to term this more as a digital twin approach. And what that means is, an approach being the key word here, that a digital twin is a methodology and not necessarily a technology. So you can't just buy a digital twin to solve your problems. A digital twin is really about how the physical and digital worlds will converge and how fundamentally you can use data throughout the life cycle of your project or your asset to allow and enrich these two worlds to connect and benefits to be delivered. Now, in that concept, we might also consider this, that if you look at digital twins, most people focus on that unicorn, shall I say, at the end of the journey, which is looking at a fully autonomous asset that's all singing, all dancing, and all these great things. But what we know is that's quite expensive to get to, and also the technology isn't necessarily proven to get there yet. But what we often see is that organizations fail to really realize that there's steps of benefit and value along the route that can be unlocked as you start moving towards a digital twin. Really talking about the fact that digital twin is a journey and not a destination. It's something that will evolve iteratively over time, both as the organization matures, but as technology itself matures. But the key around all of this is that they're always developed within a use case or particular purpose in mind. Now, moving a bit forward to some of the developments we've been seeing over the last couple of years, if we look at it like this and consider a spectrum of data from visibility to interoperability, visibility being, of course, making data visible, and so you can understand what you have and where it is, whereas interoperability being the exchange of data between various parties, either within your own organization or other organizations. Now, what we know is most organizations are really at this stage in their journey, particularly as they've come from a maybe pre-digital age, or they haven't invested in their IT systems over the last couple of years. So it's all about making their data visible before they can decide what to do with it. But what we want to do is move along the spectrum to interoperability, the exchange of data, which in the context of digital twins would facilitate an ecosystem, if you will, of connected digital twins, where digital twins can be connected together and exchange information between them, which would mean leaning towards a national digital twin, even an international digital twin, or planetary digital twin, which, as it says there, is an ecosystem, is not one giant digital twin of the entire world or entire country. It's loads of connected digital twins that work together, just like how the internet functions, for example. Now, that's the premise, is something that's quite interesting. So if we unpack that a bit further, if we consider the built environment where we live, and this is a generic pitch of the built environment, if we were to split it up into its various sectors, we might consider it, arbitrary like this, that we have the energy sector, of course, my domain, transport, water, social infrastructure, residential, commercial, and industrial infrastructure, and the green environment. Now, what we know is that data exchange might happen within each of these layers in their own right. So what I mean is the energy system. Of course, energy is balanced across the grid, and therefore there has to be an element of exchange of information between the actors in that system to allow that balancing. Similarly, with transport, there's an element of exchange within the transportation layer. But we don't necessarily exchange between energy, transport water, and so on and so forth. But if we could connect these layers together and collapse them together, ultimately what that would mean is us being able to create a digital twin of the entire built environment, with data flowing in right time, not real time, to the digital asset, where you can make decisions and then, of course, make interventions back into the physical, allowing us to take a real systems-based view of the built environment, delivering outcomes on a social, economic, and environmental level. Now, what that means in context is if I go back to my original diagram of a twin, and this is my simple generator, if you will, when you're flowing data one way and the other way, but let's switch it to a train, which might be more relatable in some contexts. If you have a digital twin of a train, in its own right, that's pretty exciting, but if we connect the digital twin of the train to the digital twin of the tracks and of the point system, then you have an information exchange between these three actors. But roll that up another layer, connect the digital twin of the railway network to the aviation network and the road network. And again, you have even more information that can be exchanged for mutual benefit between these parties. And finally, roll up another layer to connecting the transportation to the energy and the water, ultimately allowing us to get to this state, as I say, of a digital twin of the entire built environment, whereby any single twin in the system, so going back to my individual train, is able to benefit and access other information or systems from other twins in the network. Now, looking at that another way slightly, if we go back to our built environment, what we know is that every year, only 0.5% of new assets are built, which means that 99.5% of assets already exist in the built environment. And therefore, digital twins and the size of the prize isn't actually the new asset at all. Of course, every project being commissioned today should consider a digital twin approach, but the real size of the prize is the existing assets. How can you retrospectively apply the concepts of a digital twin to these assets to unlock value? Now, how do we go about doing that? And that's the key thing. Ultimately, all under the mantra of this: collaborate on the rules, compete on the game. And what I mean by that is that fundamentally it's unhelpful if individual software vendors, technology companies, or consultants start deriving their own version of what a twin should be or shouldn't be. Ultimately, twins are twins, and we should collaborate on the core fundamentals that make them what they are, so then we can compete based on the game that we've set. Now, of course, that is something that's happening, and one of the most prominent publications in this space is this one called the Gemini Principles, which sets out 9 principles by which any digital twin should consider when they're being created, which are all around purpose, trust, and security. And these are guiding principles, and I encourage you to have a look at this document. They really set a fundamental step for what digital twins should and shouldn't be. Now, after, let's say, over the last year, there's been an explosion of the talking and development around this idea of connecting digital twins together. And this is a selection of some of the different publications that have been released, each of them talking about how you could connect them, how they would work, and fundamentally what the technical architecture looks under the hood. Now, I'm going to talk a bit about that technical architecture just as in a brief level to kind of give a flavour of some of this development. But quite excitingly, if we take this document here, it sets out 3 particular parts that will allow us to create this ecosystem of connected digital twins, arguably the internet of twins. The first being a foundation data model, the second being a reference data library, and the third being an integration architecture, which I can go into more detail when we come to the questions. But picking this integration architecture more particularly, and not wanting to overburden with too much, that this, in essence, is the technical construct of how it will work. They will have an ability for individuals in the system who are data owners to allow their digital twins to be catalogued and discoverable and queried by other data consumers in a secure way using the permissions and legal frameworks that they've set. Now, how do we go about doing this? Fundamentally, there's 2 ways of trying to develop and deliver such a wide-scale agenda of creating an internet of twins. The first is a top-down authoritarian approach, where you try and create something centralized and push it to the industry, which we know doesn't necessarily work all the time. And the second is could be a bottom-up or Darwinian approach, where you allow industry to fight it out, and eventually someone will come up with a standard or solution that seems to work. Classically, the VHS versus Betamax battle, but in a system and a technological landscape like we have now, where things move so quickly, that kind of seems a bit of a waste of time. So the approach being taken by the program I referenced earlier is both at the same time, developing an information management framework, which is a specialist-led top-down standard, whilst at the same time developing a practitioner-led bottom-up standard that come together and supported by a demonstrator of this concept working into a model that will allow us to create and enable the connectivity of digital twins together. All of which, as I say, is wrapped up in what I term the National Digital Twin Programme, which I can talk about in a bit more questions. So moving very swiftly on to what does this mean for us as ARUP, and wanting to give you some examples. So ARUP have been working with digital twins for a number of years. We've put out 2 publications in particular that talk about our views on this. The one on the left being particularly on digital twins, and the one on the right being our views on creativity with data at scale. Now, what these manifest in ultimately is our process and our way of delivering digital twins. In our view, it's a simple way of 4 steps, starting one side and always looking at the use case and why you want to do it and how you're going to do it before moving on and building and maintaining your twin, while then ultimately developing its maturity and continuing to be current and value adding going forward. But without labouring too much what that looks like as a process, what I'd like to share is 2 real quick examples of where this has been done in practice. The first is a project we did in Hong Kong, actually, with a building developer out there using a solution we've termed Neuron. And you can see the web link in the bottom corner if you'd like to learn more. So in Hong Kong, 90% of building electricity usage is actually through HVAC, so heating, ventilation and air conditioning. And therefore, accurate usage forecasting and optimized control can provide a significant energy and cost savings. What we did here, and in doing this project delivered Hong Kong's first digital twin building, if you will, is integrate BIM, IoT sensors and analytics to deliver this data-driven smart building, saving what was up to 30% of energy for the building. And that's looking at things like future temperature, future occupancy, previous temperatures, and bringing all these things together with some analytics to understand how you can optimize the building and provide the energy saving that I said there. More information I can share later, but you can go to the website yourself and see a bit more. But a fantastic example of how you can bring different data sets together using analytics to provide insights and ultimately a saving to a client. And the second one I'm going to really quickly touch on is this Queensferry crossing based in Scotland. And again, the web link is in the bottom corner, whereby this bridge was commissioned and installed over 2,000 sensors into the bridge that can monitor all of the attributes and parameters associated with it in right time, again, not real time, looking at how the bridge can respond to extreme weather events. So looking at the sway, the temperature, if there's snow on the bridge, the rocking, the vibration, and using that to then model and understand where you can preemptively maintain or how you can reduce the number of cars or increase the number of cars over the bridge, ultimately allowing 24 million vehicles to travel over this bridge every year. So a lot in those two, but the last thing I'd like to leave you with before handing over to my other speakers is this. How can we move forward with digital twins today? And I think it's really encapsulated by these 6. The first is embrace the concept now. All new projects that are being commissioned should consider a digital twin approach. And that's the concept of a digital twin, not necessarily buying a digital twin, because remember, it's not a product or technology, it's a methodology and a way of working. Respect the journey now and recognize that ultimately the unicorn is where we want to get to, but there's milestones of value across that journey that we should look to unlock, again, based on the use cases we're trying to deliver. Collaborate is all about working together and coming out of our silos and getting everyone involved in the conversation. Going to the regulate piece, there's a position for government and industry to work together to lead and drive national policy on this. And finally, moving to the last one of being sustainable, that adopting this concept and applying it in the correct way will very much help us move towards a sustainable future when it comes to all of our buildings and operations. So that's the concluding of what I wanted to share today. Links on the screen now if you would like to get in contact. The last thing I will say, if you were interested, is there's a couple of people from industry have got together and started a very informal podcast called the Digital Twin Fan Club. The name is intentionally tongue-in-cheek, but we've had some really interesting people interviewed on that, including Dr. Michael Greaves, the NASA rocket scientist who famously created the term digital twin about a decade ago. But my final point is digital twins is an approach, it's a methodology and not a technology. It's a journey and not a destination, and something that all projects should be considering today. And over to you again, Alan, if I could.
Thank you, Simon. Fascinating. Fascinating. My apologies about the earlier interruption. I had to talk to one of my teenagers to turn down his stereo system, so sorry about that. Really, really interesting. And I also believe that the Centre for Digital Build Britain have a regular webinar. Is it every Tuesday? They have a regular webinar on this, and so that together with the podcast, I think that's something that certainly I'll try to look at myself. I mean, the 99.5% challenge is a huge one, is it not? You know, that you have all of this existing physical piece. That could aspects of that be retrofitted? You know, could we retrofit the BIM? Can we, is that possible?
Absolutely. And it's all about finding exactly the use case you're trying to answer, because in a lot of these contexts, the fundamental thing it relies on is having information management in place, which for the built environment, we often term as BIM. But of course, there's other factors in it as well. So how you retrospectively do this is find the use case you're trying to address. You know, is it asset management? Is it building efficiency? Is it occupancy optimization? And you work out what information and data you need to address that use case, and then you get that data. And then from that, you can answer the question. So very much. And
so many synergies with BIM, and I suppose a digital twin is dependent on BIM. BIM is only part of the solution, as you say, IoT. Yeah. Connecting the IoT and the sensors, that creates the intelligent twin. So yes, we have one or two comments in there, if I may, Simon, before we move on to a second speaker. Ralph, you're very welcome. Ralph Montague of MarkDocs has a question for Simon. Are you aware of reference to reference architecture framework and the work by DigiPlace in EU and the CDBB work on National Digital Twins? Is there an overlap between these projects?
There's overlap and synergy in the two. And what I mean by that is that naturally most countries in some capacity are looking at developing a version of this. Often if you look under the hood, they are the same core concepts, just being looked at in a slightly different way. And there's a huge amount of international collaboration happening between these various programs. So whilst there might be in some places it perceived as an overlap, that a duplication, actually often that's the case. Is it's knowledge sharing, information sharing to make sure that these things are all compatible together. Just like there are, for example, many different languages and ways that the web can function, but fundamentally the web works on a kind of underlying architecture. That underlying architecture is what is being built consensus around at the moment, but you can have loads of languages on top of that that allow different things to be answered. So yeah, there are synergies, overlaps, but also huge amounts of collaboration happening with that project in particular and the work by the NDT.
I just popped a comment myself into the chat there about, I was surprised the 6 points you raised at the very end. I didn't see reference to return on investment, the business case. So my question is, could a digital twin, say for example of an office facility, add value? Could the building become more valuable as an asset as a result of investing in this technology?
I would say absolutely, because if you can derive the insights you derive from a twin can provide efficiencies and value to a building. But what I think would be more interesting in the way of answering your question is what we know is that, let's say, financial standards and reporting, they take a number of years to update, 5-7 years before standards capture things they're talking about today. But we've already heard that the accounting standards are looking at how you can recognize data on the balance sheet. And we've also heard from financiers and insurers that in the future, they might be asking for digital twins of buildings in order to commission them or insure them or finance them, which is an interesting concept. And then if you look at tenants could also be demanding a smart building or a digital twin enabled building to charge a high premium on rent. So absolutely, I think if you do not consider these concepts now, all you're doing is creating a dumb asset for the future, and a dumb asset will be less worthwhile or have less value than an intelligent asset that considers these concepts. So yeah.
Yeah, and of course there's been a lot of debate around, data being the oil of the industry. And digital twins being the combustion engine, so like if you have the data structured, the building just becomes a living asset.
Exactly.
Which is so powerful, isn't it? I mean, the fact that there's no point in the future of building dumb assets.
No, not at all.
It's pointless.
It's literally
and the building, yeah.
And that's the problem, because right now, digital twins, because they're so high on the hype cycle, they're value engineered out of the program. So a new building will be commissioned and people go, I don't need that, it's too expensive. But that's such a risk. Even if you just understand how you might do it, so have a strategy, that's all you need. At least have a strategy for how you could do it in the future.
I mean, there could be a premium on the rent, a premium on the sale as a result of this, Absolutely. So listen, thank you so much. I could chat all day with you on this one. It's my new area of interest. Thank you, Simon.
Well, the new asbestos. I'll throw that. You said digital's the new oil. I've heard the other one is digital and digital twins the new asbestos. Where in a few years' time it'll be negative. We'll see. Anyway.
Oh, right. Okay. Interesting. So, thank you very much, Natalia. You're very welcome.
Hello.
Natalia is known. I've spoken before at our events, and EVERCAM are a great supporter of the Alliance. So, Natalia, over to you. You're going to be talking about fixed camera positions and full video recording and how this can add value to an input to the construction digital twin.
Yes. How do I present? Here. You should
keep the questions coming in, please, if you can. Thank you.
Yes, definitely. I hope you can see my screen now. And
yes.
Thank you for inviting me. I'm a little intimidated speaking after such an accomplished speaker presenter just before. Thank you, Simon, for this beautiful presentation. I'm Natalia Pinkovska. I work at EVERCAM Construction Cameras as research manager. I'm responsible for partnerships for our research and innovation programs, and also partly for our user discovery processes. We tend to talk a lot with our users. We tend to observe the industry closely. And what we see these days is that some kind of video recording is happening on most of the construction sites. It can be from various sources. It can be from drones. It can be from walk-around cameras. There is recording with mobile cameras of certain events. But what our solution promotes is the fixed position approach. So we install cameras that stay there for the duration of the entire process. Now, construction and technology, especially the digital technology, do not always tend to go hand in hand. And we all know it, that there are so many issues on the complex sites. Definitely the costs accumulate when we have disputes, when we don't know what's happening, and costs and delays can diminish the premiums of the general contractors. Now, the issue is in our view, the visibility. When we do not see what is happening on the site, then we cannot solve the problem. So what we offer is a tool that offers visibility, transparency, and enables visual communication throughout the team. Now, what's important for the digital twin approach? We record everything. When you record everything that happens on the project, you can later come back to it. You can also extract valuable data and input it into the build asset. When you buy orange juice in a supermarket and there's something wrong with the juice, you can go back to the store will go back to the producer, and the producer will be able to trace every component, every ingredient that was put into the juice. When there's something wrong with your building, you rarely can go and trace back what has been done wrong in the process of constructing. What we offer is this possibility to rewind, the possibility to look back at when this pipe was installed and at when this pillar was poured, when concrete was delivered, etc. Now, I would like to walk you through our system a little bit and current capacities. I'm sure our brilliant salespeople are much more accomplished to give you this presentation, but I would just like to do it very fast. So basically, what we offer now is the possibility to see what happens live on the project. So this is invaluable for project managers who can check remotely whether the work that they asked for, the work that was planned, has been done, and only later arrive at the site and inspect it in place. Again, we record everything. We store it for the duration of the project and afterwards. And you can always come back, you can always see what happened at a certain date, at a certain point. We create these beautiful time-lapse videos where you can see how the buildings grow. Compare tools can help you see the past and present or any chosen dates. You can zoom in. You can also mark up certain areas and share with your team. the X-ray is like a small compare. So again, you can see what happened before, how the building, the area looked before this, for example, curtain wall was fixed, but it's only in this small snippet of the screen. Sharing is easy and quite broad. So we have cameras where 40, 50 people are looking at one camera from various roles, and each of them draw their own benefits from these cameras. You can schedule regular updates. And what is super important for us are these various software integrations. We believe in an integrated approach. We believe in standards. We would like the construction technology to speak to each other and to share data from one to the other. Now, what's more advanced and probably much more relevant to the topic of this meeting are these these extra features that we are integrating in the camera view. So first of all is the integration of the BIM model. On the outside, this is a visual integration where you can see what should have been done, what should be done in the nearest days, and you can also see the camera picture aligned to prove that this has actually been done or not yet. Now, what's on the back end of this, from our brilliant software developers, is that they automate this alignment, that they also read from the picture what certain elements represent, and they can so that in the nearest future the BIM and the camera will be in fact able to speak to each other and update. The camera picture will be able to update the model and in fact create a part of the digital twin that will represent the true asset. What the BIM tool enables us also to do is to measure from the camera. Of course, this is a tool that mostly serves overall general verification, but it's still nice to see quite broadly used by quantity surveyors, for instance. We apply artificial intelligence on various levels of the computer vision capacities, and one of the products that we have launched is called Gate Report. We recognize all trucks arriving and leaving the site. We can categorize them, and we can tell the customer how many trucks delivered certain materials, how many Mackaway trucks were there. What's interesting and what we are working on here is, for example, such capacities as whether the trucks are full or empty, and whether they arrived at the right place and the right depot on larger construction sites. Now, again, why does camera work well as a source of data for the digital twin? Camera sees it all. Camera records it all, and we can always draw data out of this recording. What we are doing at EVERCAM is collecting this data and visualizing it in a model, so that this model can be later used to feed into the digital twin. The data that we read can be at various stages of the construction. So we can, for instance, create these areas where we will see what a depot is and how full it is at a certain stage for the planning purposes. Where we see the areas that will be built, will we see the back office. This is a visualization that could show the opportunity, the possibility of visualizing the BIM model on top of the site when it's already above the ground. Now, EVERCAM R&D is quite developed into the integration side. So we like to work with other sources of data. We like to collaborate with other technology providers, and we will be working with TU Dublin and Gagamuller on a project that would integrate further the BIM model and sensors, kinds of trackers for workers and for the construction equipment in the construction cameras. Yes, this is the end of my presentation. I would like to thank you very much for the opportunity.
Thank you very much.
Speaking about the cameras, and thank you.
Thanks very much, Natalia. As a quantity surveyor, I'd see it being very helpful when one is preparing interim valuations, maybe claims, extensions of time. I can see this being very powerful in order to demonstrate where one is at the position of the project by way of claiming for percentage of work done, maybe dealing with disputes that might occur that could be quickly resolved through the use of the camera technology. But you can see now that really digital twins help in creating a more modern construction production process. You know, so while Simon was talking about the bigger picture, the planetary digital twin, I mean, my children's children probably won't get there, but you know, as far as looking vertically at the project, you can see the power of what you do, which is really interesting. Do we have any questions?
Maybe I want to make one more comment if possible. To refer to what Simon was saying about this route. So obviously what we offer at this moment is mostly a project management tool. So it's a tool that helps the construction itself, that helps the teams on the site. But I think it's quite indispensable that we collect all this data, all the data that we can, to be able to create the digital twin that will help the maintenance in the future. And in a way, what we're doing and what we're helping it with, and probably not yet using enough, is the possibility of extracting all this data. And I believe that our approach helps us.
And I know at DigiCon last week, there was a lot of talk about data analytics and, you know, the need to clean the data, cleansing the data, so you only need the data that's actually needed. But, you know, it's great to be working with the likes of EVERCAM on this project, the DTIF project, and probably worth just briefly mentioning that, you know, we looked at 3 challenges for the sector. You know, the productivity challenge, you know, it's no point in we all know about the productivity challenge. By implication, the non-productive challenge or the non-productivity is causing a sustainability challenge, more rework, you know, variations, changes as a result of incomplete information. And then, of course, the communication challenge, you know, the fact that it just makes sense to work with models and to create digital twins. That is the future, and that's what's going to happen in our sector. So thank you very much, Natalia. Unless you have any other questions, I know Simon just put a comment in there that he's going to get us to listen to Michael Greaves' presentation. That could be cool.
Yeah.
And that's great. Thank you very much for that, Simon. And thank you again, Natalia. So
Thank
to our
you.
third speaker, and we're a little bit ahead of schedule. Actually, we're bang on schedule, which is great. Isaac, you're very welcome.
Hello, thank you. It's it sounded like you prepared that conversation about data and you know, prerequisites for future use of software and sustainability. Thank you for that little introduction to what I'm going to talk about.
And so me and my ugly twin.
That's right. Let me just share my screen.
You're not a twin yourself, are you?
I'm not, no. So,
okay.
But I do talk about that a little bit later. Can you see my screen? It should be blank.
Yeah. So just to encourage any questions, please, in the chat. These people are, you know, these people here today. So if we could have any questions, it'd be great. Thank you.
Perfect. Thank you. So I'm Isaac. I'm a Solibri account manager looking after the UK and Ireland. Been here for a few years, 3 years coming up, actually early July. So if you want to talk about Solibri, then talk to me. I'm more than happy to have that conversation with you about whatever you need. But today I am taking the digital twin and we're going to make it a little bit ugly. And I'm going to tell you about why the concept at a moment's time. And yes, that is Gollum sat next to me. And no, I don't have a twin that looks like Gollum. So I'm going to read this word for word because I want this to resonate. And if I don't read it word for word, I probably won't say it as effectively. So in our advancing digital world, accuracy of data has never been so important. BIM simply cannot deliver on its promise unless models are fit for purpose. And subsequently, we cannot use digital twins unless models are compliant, reliable, and accurate. And informed decisions can really only be made if both the geometry and information is correct. So hopefully that resonates on what I was saying earlier and what the presentations from Simon and Natalia and what Alan said leads us up to this point. So I'll introduce you a little bit to what Solibri is all about, and we'll get into a little bit more on this later on. So over 500,000 users, been around since '96, massive advocates of open BIM. We use IFC file formats, you know, Bcf BIM collaboration format. We can always talk about that a little bit later. Global company, checks. So let's talk a little bit about checks, so rule sets. So this is how we assure the quality of our information, our geometry, our models, our data, everything that we have. And there's millions of those done every year across all of our valued users. We are a Finnish company, part of the Nemetschek group, which was, we were acquired by Nemetschek back in 2015, but we're headquartered in Helsinki. And we really were the first to bring comprehensive QA and QC to the industry. So I'll elaborate on that too. Credit where credit's due. Let's talk a little bit about what is a digital twin. So culminations of both the virtual representations and physical assets. And I want to get really simple with some of this stuff. I want to just take it right back to its roots on what a digital twin is, generally speaking, and then we'll relay that to the construction industry. So the idea of a digital twin in construction is to provide a sustainable solution for facilities management. And really the overall strategy is just making sure that what we're designing and what we're building is fit for purpose and it's being used as designed. So the benefits of digital twins, and yes, the list is a little bit endless, but we can talk about risk assessment, visibility, performance, maintenance. Let's take you know, the real time versus right time mentality there from Simon. You know, monitoring, improved financial decision making. We can talk about security. We can talk about data management. But as I said, credit where credit's due. Dr. Michael Greaves, who first came up with the idea of digital twins, the concept of it in 2002. Obviously used with NASA. In the top right image, you can see a little insight into that. But really the gist of it was to improve operational sustainability. So the ugly twin concept, and we'll get into this now. So this is where, you know, you can take the concept of an ugly twin or even possibly becoming evil, like you look at Bart Simpson up in the top right corner there. And in construction, we cannot really afford for either to exist. And a huge factor for what defines a successful twin comes right back to BIM at the earliest stages, and it comes to data. And unlike human twins, this is what I mentioned, you can actually plan for digital twins and the future use of them. So without both the matching correct data and the physical assets in the real world, this workflow is going to fall down. And unless we're transparent and really clear about this, it's going to come back to the beginning. And like any project, any preparation we ever do, you've got to start right at the very, very beginning. So we know about our outstanding industry challenges. They've been spoken about a little bit today: project performance, labor shortages, sustainability concerns, asset performance, environmental concerns, lots and lots of things. But digital twin methodology, and yes, I did have technology in there before, and I changed it to methodology. Thank you, Simon. Could be the answer to a lot of these challenges. So I've mentioned a lot of these already, but whether we're measuring assets, processes, people, places, systems, they really do hold a series of benefits and purposes. So in construction, naturally, we could be testing new assets before launching them, because issues are going to cost a whole lot more when they're at later stages. And what Solibri is all about really resonates with that as well, because finding issues earlier on in the design phase costs us a lot less when they're at construction level. So practically, this type of technology can really improve both safety, efficiency, building meets sustainability or regulatory requirements. And another really, really important thing to mention here is that not only can digital twins predict a failure before it happens, they can even prevent them from happening at all. So from BIM to digital twins. So this is my layman's terms introduction to really what BIM is with digital twins. So everything starts with an idea. Those ideas are going to roll into strategies. Sorry if you can hear the ambulance drive past there. Strategies then evolve into concepts. From our concepts, we've got our plans. From our plans, we have our assets. And this whole conceptual phase through to the asset stage is really what we're, let's say, classify as building information modeling. So from there, those assets that we build require maintenance. And we're going to now take our digital model and our physical asset, and the digital model can be used as that central repository of information about the physical asset. So maintenance work can then be foreseen, can be automated, it can be accelerated. We can monitor a series of things that I've sort of already mentioned already. Iot Sensors will be the methodology to provide the information about the physical asset back to the digital model, hence creating this open communication between the two. And therefore, facility managers can really utilize the 3D model to plan and review the required work. And that's sort of digital twins. So there is a point in time where they get introduced, but if you don't consider them at the BIM stage and you don't consider them at the design stage, you can see how that would fall down. So let's just take the preparation for digital twins. So we can define an architectural roadmap. We can talk about what sort of data feeds and what sort of information we want to monitor in our digital twin environment. It might be both simulations or predictive maintenance to be the areas where we can offer best value. And naturally, it can be used on a project to expose just how well that project connects with the current state. And we can look at some of those examples that Simon showed earlier as real-time, examples of this. So the records that are incorporated from these diverse data points, which Natalia has obviously spoken quite a bit about, just in terms of data population and all the information that we have, well, the benefits exceed themselves. So it includes just the ability to really, test everything I've said. I don't want to elaborate too much because I've said so much already, but let's take that intelligent master data system and the transformative benefits of digital twin technology. And just to throw it out there, and I screenshotted this from you, Simon, as well, whilst I may have struggled to put that and articulate that sentence, myself, I nicked yours. So thank you for that. It's the best way to talk about preparation of digital twins. So I will reuse that. Sorry, not sorry. So let's talk a little bit about BIM. So we're going from strategic definition through to conceptual design. And naturally, the progress of any BIM project is really reliant on both information and coordination and the accuracy of it. So BIM maturity is growing a part of the digitalization megatrend. In fact, even the terminology of both BIM and the digital world is up for contention, but the benefits of using BIM are recognized and more BIM files are being created each and every day. Both authoring tools, and I come from the vendor perspective, being prepared and ready for the job, which I'll get into a little bit of detail on later. Another thing to mention here, ISO accreditation 19650 is becoming clearer and clearer for what is actually high quality. And we are seeing a lot more, execution plans being created and BIM requirements becoming clearer and clearer. And not just, in the UK, we can take this from a global point of view about the mandating of BIM, across lots of different countries now. So what is quality assurance and quality control? Well, it is a lot more than a design coordination. So how we prepare for digital twins and how you prepare information for things like COBE and other sorts of deliverables, building regulations, standards, fire safety, whatever it is that you're wanting to check, it all comes under that roof. So, and there is a growing awareness of what quality related problems are, and Solibri offers a solution for those. So choices made in the design phase, and again, I don't want to say this too many times, will have such a significant impact on the life cycle cost of buildings. And again, the cost of fixing errors are a lot higher at the construction phase compared to the design phase. So let's talk a little bit about the I of BIM, information. And that is really the critical part of all of this and how we prepare for the future use of models and all the data that we create. So we've seen it all before, all of these different measurements of how we define quality, how we measure quality, what we're doing to review progress in our industry. Well, we've seen lots of different ways in which we've managed to sort of mitigate risk or control quality. And I suppose we'll get into a little bit of detail on Solibri's position of that. So let's talk about measuring issues. Well, we hear this quite a lot. We hear measuring quality is subjective. We hear that it changes from project to project, not having the right information at the right time. And yeah, they're all valid statements. They are things that people are experiencing each and every day, but it shouldn't stop us from being progressive. And traditional approaches to measuring quality have been to review a project after it's built and to take that building as a physical asset and then review how well we have a job we did to get there. Very reactive. And the question is, can we actually afford for that to happen? So do we learn from those mistakes legitimately? And can we really let them happen in the first place to learn from them? And have we learned from enough already? So I'm not going to say that because that line's been said 3 times already, but the cost of fixing errors is a lot higher. So sorry, that's in there again as well. And it's time to get preventative. It really is. That's the best attack is being proactive, and that's exactly what we're proposing in this presentation here, is to be able to identify issues, have a robust reviewing process in place, consider things like interoperability and communication and stakeholders. And that's why we talk about Open BIM quite a lot. It's because we're talking about making sure that everybody that's accessing this project and the information and the data and everything to do with it can actually access it, and the Open BIM strategy and the Open BIM mentality is being really catered for. So let's talk about accountability. So we talk about this quite a lot, but you can take Grenfell Tower as one example of a great concern for safety, and insurance companies are becoming a little bit more privy and conscious about what the workflows are at the design phase for quality. So whether you're taking that building and you want to check how it's been performing and ages over time, then this is where digital twins really comes in, and I'll read this word for word because this I put in here, and I want to make sure that it's nice and clear. So at the most advanced level of a digital twin, it can be a lot more complex and multi-layered than maybe how I've laid it out before. So whether we're incorporating both the virtual projections of whatever we want to do, processes, people, data, maintenance, this is a scale of which we are starting to see is being advocated by the UK government, and the intricacies of both model management and infrastructure is really about making informed decisions so that we can prepare for this stuff. Congestion, climate change, possible risks. A model of complexity is going to be incredibly difficult to build a digital twin for unless there is this contractual framework to govern. So we can talk about data ownership, we can talk about causation, liability, and they can actually all be unclear. And to play devil's advocate on talking and screaming about the benefits of digital twins, well, there are obviously infant stages of these discussions that we're in at the moment, and they can be quite contentious. So, do we actually consider the legal obligations of our actions and the risk if we can't ensure the quality of that? And what happens when a BIM project has actually progressed to construction level if the virtual models contain errors? So I'll get into a little bit about Solibri now. I'm conscious of time, but I'm going to fly through this as quick as I can. So whether we're talking about those time savings, cost savings, environmental savings from a digital twin perspective, well, Solibri offers a very similar solution when it comes to assuring the data in the BIM phases. So let's take all of these into factor, whether we're looking at interoperability, these are all on our roadmap, all on our major considerations for everybody that needs to quality assure what they're doing. And we'll get into it. So at the design phase, naturally, we want to be correct prior to delivery. We want to be able to check against our BEPs, our BIM execution plans, and we want to make sure that we're aligned with our other stakeholders in the project. And that sort of runs right through from BIM coordination of finding those issues early on, communicating, collaborating, and innovating with others on the project, and through to construction, where hopefully we don't see as many issues, and those quantity surveyors can take off information from the models, and they can communicate with each other effectively because the information is fit for purpose. So what does Solibri offer? Well, this is sort of our workflow, and I won't talk into this too much because it could take a bit of time, but we can federate our IFCs, we can take our IFCs into Solibri, we can coordinate properly in there, we can classify components, we can really identify what they are, the nature of spaces, both components across architectural, structural, ventilation, all these different models. We can then check the things. So we can define our checking processes against, the BIM execution plans or just our building standards, and we can identify problems before they get to construction level. We can base those problems on severity, and this is sort of the big capsule of what checking is within the Solibri environment, alongside model revision management to see what's changing through the life cycle of a project. When we get to the communication part, Solibri offers solutions such as Bcf Live Connector, which enables us to integrate with cloud-based tools. We've got both the ability to export BCFs, we've got APIs there as well, but really what we're trying to do is get to the point where information is being delivered, whether it's information takeoffs, whether it's COBie, that the information is reliable and it's fit for purpose, and that's fundamental. Today, in the last few minutes, I'm going to talk a little bit about checking. So what do we do when we check? So there's a list of things on the right-hand side, as just some common examples there. But the physical process of checking things in Solibri can be done a number of ways. Whether you're visually, looking at things using like a model viewer, whether you're searching for components, exporting without information takeoffs, and doing design verification for a cost-X system, costing systems, whether you're wanting to report, from BCFs or look at other people's creations in Solibri, or whether you really want to get into the nitty-gritty of what rule sets are all about. We're going to focus on the rule sets today. So looking at a much more reliable and sustainable way of meeting building standards and regulations prior to the construction phase. And it's not just about geometry. Solibri is a huge advocates, and we all are, for data. So how do we combine the data world and the geometry of those models? And naturally, it's going to be cheaper to find them at the earlier stages. So we can do these sorts of things. And this is really what I wanted to show. I'm not going to jump out of my presentation into a software. So I wanted to just show you in the presentation environment, whether you're checking some pretty basic gatekeeper sorts of checks, make sure that my building has got, unique identifiers, make sure it's got doors and windows associated to certain spaces or walls, make sure it's got model hierarchies, all of these things are needed. So what are we doing if we're not checking them in an automated way? Well, we're probably checking them manually, or we're not checking them at all. So whether there's components overlapping, we've got duplicate components here, and our rule sets in our software aren't just devised by us sat there scratching our heads thinking, what do they want to see next? We listen to our community of users and say, what is it that you want to check for? And this one was devised from a customer that said, my wall components are not stacking up in my information takeoffs. Can we have a check as to why? And funnily enough, there was a wall within a wall, and you couldn't see that visually. So the rule managed to find it through this overlapping component rule. There are a lot of other sort of clearance-based checks. It's not just about clash detection. It's about looking at the spaces on either side of those components and defining if they actually have purpose and need to move. So we can take our window components and see what's happening on either side of them. And in this case, in this rule set on the screen on the right-hand side, columns were protruding through the window space. There's lots of other ways in which these clearance-based checks can be used on a number of components. So we are really checking for all sorts of clearance-based requirements across the model. Whether we wanted to get into data, so these staircases actually didn't have the proper construction type information for them, so we're doing database checks now, not just based on the locations and the the clashes of those components. These don't have the information that's needed, so it can get flagged up. These columns are supposed to be supporting the slab above. They're not. It's a floating slab above. So naturally, that's another problem that Solibri's managed to locate using this tool called components below and above. And that can be used across a number of components. You're not limited. Solibri is a canvas. It's not a blank canvas because every single rule I'm showing you actually comes out of the box, but it needs to be tailored and it needs to be adjusted for the project and the way in which you design. So it's a journey and it's a cultural change, and we appreciate that. Whether it's deficiency detection, looking at building regulation standards here to check to see if there's swinging doors within proximity over a revolving door. There's lots of different things, spatial-based checks, construction type-based checks, space scheduling checks, accessibility-based checks for turning circles in toilets here. We've got, as you can see, the radius of the red circle in the purple image in the bottom indicates how big the turning circle needs to be, and the green represents what actually is available. Therefore, it fails to meet the standard of a 1.5 meter diameter radius. Whether we're doing egress analysis, whether we're doing fire stopping, fire safety, fire zones, as you can see here, escape routes, wall requirements, the minimum door dimensions. We can even take missing components into the factors here, so we can say what those spaces actually require from a component list point of view. And then as things change and things get fixed, we might want to see what's changing throughout the project. So there's a ton of different things that you can do. And that's, I suppose that's a part of what I offer from Solibri is if you want to start this conversation with us about what we do and why we do it, then feel free to have a chat with me. But fundamentally, when we do things like COBE and information takeoffs, if we're not doing all the checks in place to begin with, then how do you validate and ensure that those models and that data is fit for purpose? And I won't go into too much on this just because I've got about a minute left, I believe. But let's hear it from our users. And this isn't just a reflection of Solibri. This is people that have used Solibri on their projects and the importance of both data for DFE projects, whatever it is that you're working on. I've got Nigel here at, Tideway talking about, what do you want to ask Solibri? What do you want to check for? And Solibri, you will be able to deliver it for you. We can take, quantifying the value of finding these problems. Well, I've mentioned that they cost a lot less when they're at the design phase to the construction phase, but well, how much? And we can take efforts like 400,000 euros on a project by finding issues that we wouldn't have found before. We can talk about really innovative designs and projects like Wood City in Helsinki. And if you ever want information on these, we've got plenty of, articles and videos on these. I think even B1M have got a video with us based on Wood City. Whether it's Rob Jackson talking about the value of finding issues early on as well, and the benefits of Open BIM, and is a big advocate for both Open BIM and COBE and Solibri, which is great. So Tim Cox, another example, DFE projects. Well, he wouldn't have been able to deliver the COBE data had he not had Solibri in place for 6 new build projects that they were working on. So this is our community talking, and really just to sort of end with the statement I made right at the beginning. In our advancing digital world, accuracy of data has never been so important, and BIM simply cannot deliver on its promise unless those models are fit for purpose. Subsequently, we cannot use digital twins unless models are compliant, reliable, and accurate. Informed decisions can only be made if both the geometry and information is correct. And the earlier that we consider the accuracy of our data, the more likely we're going to end up with digital twins that look a little bit less like this one and a little bit more like this one. So thanks everyone for joining me, and that's everything from me. Back to you, Alan.
Thanks, Isaac. I think you did a great job in kind of closing the loop, and like the way you kind of constantly went back to the accuracy of data and the importance of BIM, because I suppose that's been kind of preoccupying our thoughts over the last number of years. And as Simon said earlier, the last 3 years has been more about digital twins, but it's all interconnected, if when you think about it. And so it just makes me wonder for a minute about dynamic models and dynamic twins. And we have a building control system here, we call it BCAR. With respect, it's not particularly dynamic. I mean, have you come across any examples of where the functionality that you have is more dynamic in that building control can be better managed dynamically and digitally?
Yeah, good question. We'll put it this way. Everyone's sort of looking at the cloud at the moment, and when we talk about interoperability, everybody's mentality is to get data and access to this sort of information and these sorts of challenges to the wider audience for the people that are working on this project. And whilst Solibri is a desktop application, the integrations that we're working on with cloud-based tools like issue tracking systems, information management, like CDEs and those sorts of tools, then it really helps us to get the image and the actual collaboration out there for what Solibri is all about. And finding these problems are integral. Whether you find them difficult in Solibri or really, really easy in Solibri, what doesn't change is the requirement for them. And whether you're doing them or not, all of these projects, BIM projects, need to be quality assured and fit for purpose. Solibri provides a solution for that. And now we're stepping one step further in this year and talking about not just usability, but interoperability. So it doesn't really matter what other tools you're using to do basic things like clash detection. Solibri is trying to get the message out there, and those sorts of interoperable tools working with us.
Yeah, so thank you, Isaac. So 3 fascinating presentations, really. And I suppose we sometimes forget that a lot of the innovation comes from the the tech companies and the vendors. I mean, you know, we forget that you're the people that are, I think, Natalia, you refer to the very clever people that are building your software and constantly adding functionality, and you talked about additional features constantly coming on. And, you know, Simon, you spoke about the Neuron project. I'm sure that's developing, that solution, that app is developing. And I'm sure, Isaac, your product is constantly developing as well. So listen, I might open it to the floor or to the, whatever you want to call it, for any questions that people might have. I know maybe people hadn't time to pop it in the chat, but I see lots of familiar names. They shouldn't be shy. You should be able. So anyone just going to come in with a question? It's a bit like when I'm talking to my students. You put your camera on when you know they're probably in their PJs in bed, you know, not listening. But I'm sure you were all listening attentively. Any questions for our speakers? No question. I have a question. Which industry would you say uses digital twins the best today? Is it automotive? Is it is it aeronautical? What is it?
I put my hand up there, but realised that.
Yes. Any questions, Simon? You've obviously looked at other industries.
Yeah, so I was going to give you my response to that. In my view, it's manufacturing and aerospace.
Right.
Looking at it and have been using it really readily for 20 plus years. They might not have been calling it a twin, but the construct of how they're using it has been around. And I think the classic example is Rolls-Royce and their Trent jet engines. You know, the jet engines have been deployed in the field. I say in the field on aircrafts all around the world, and they're monitoring them live. And as soon as they see a problem, they can send a service team to the ground even before the plane's landed. And that construct of using information to inform decisions is ultimately a twin. And they've been doing that for what, 15, 20 years? So it's those type of examples. That and F1, for example, the amount of sensors in an F1,
oh yeah,
crazy. And that's completely simulation driven to get the optimum lap time.
Yes,
I think it's
absolutely.
really interesting. I was just going to add to that as well. It's very interesting when you think of these different industries as to why, you know, what are the motives for why they've got digital twins at a more advanced level? Is it aerospace because it must be an absolute nightmare to change a tire when you're in space? But and like Formula One, you know, is the reason why they've got better digital twins because of performance related, you know, motives. And so whether it's cost saving exercise of maintenance in space or the ability that we've got feet on the ground and they're, you know, miles and miles, thousands of miles away from us, what's our motive in construction? And is that motive apparent to everyone else that isn't a facility manager?
And I think what makes it, yes, Natalia, you want to come in there?
Yeah, I wanted to refer to the construction's needs. What I'm thinking about is the cost of actually pulling the wall down to see what's inside, yeah. And we've been doing it this way for so long, for ages. So when you have a plumbing problem, you can't identify it. So just tear the wall down, you'll see. And we do not appreciate the possibility of just seeing it first and then checking on the side. Yeah. So the change of mentality is surely needed here to deploy at large scale.
I think what's a little frustrating for me and for some of the community here in the world of digital construction is that it seems to be, certainly in Ireland, that we're trying to, the industry and in fairness to academia are trying to figure it out, whether that's developing product, whether that's improving business processes, or whether it's like DTIF, where maybe industry and academia work together, like what's happening with CDBB and so on. But what really needs to happen, I think, is that the government and the policymakers in the industry need to get the best people together to figure this out, because it just makes such sense to do it a lot better than the way we're doing now. So fixing the productivity problem, fixing the sustainable issue, you know, responsibilities that we have under climate change, and also just being better at the way we communicate and so on. That's really, really interesting. Yeah. So thank you so much We've got a question from Paul Tanzi. Is there one platform software or a multiple of platforms used for developing and managing digital twins? Thanks, Paul.
Great question. Excuse me, in answering that, there's no one software to make a digital twin, just like there's not one CAD program to make a CAD model. There is a multitude that can be used. And I think the key thing to look at is that it's always going to be a constellation of technologies that work together. So it's not about having a single source of truth, as you another hear misnomer, which kind of alludes to having one giant system that will ingest everything. It's a single version of truth. It's systems talking that will connect. So you have a digital twin could be provided by one enterprise company that will connect to another system that also provides a digital twin, maybe of the organization that connects to the finance system, all of those speaking, rather than just one company can give it to you.
Yeah, and of course the glue is the internet, isn't it? And
or the twinternet.
Oh wow, that's a new one.
Twins. That's the other one.
The twinternet.
The infrastructure that connects the twins, either between different asset owners or within your own organization, is the core part.
But in order for digital twins to talk to each other, or for software, or for the internal workings of the twin to talk, you need to have the internet. You need to have connectivity and IoT. And all of that good stuff. Okay, so unless we've other questions, we might start bringing it to a close. It'd be great to finish up a little bit earlier. I know everyone is busy. It's a busy time of year. It's a holiday period. The weather's good. Where people are away on holidays. But I think the presentations, guys, were really, really fascinating. Of course, people will get a chance to look back at the recording. So what I might ask Shannon to do now is just to pop up some things I want to announce. Okay, so we are planning a significant event in September. This is the 5th BIM gathering. We started back in 2013, and we had, I remember in Galway in 19, we had nearly over 450 people at it. We want the same again for September. We need, we're looking for a strong gathering. We're focusing on construction innovations for future generations. I suspect this is one topic that is going to constantly develop, and our children, our children's children, the next generations will all figure this out for us. But we're going to be focusing over 3 days on 3 particular messages for our industry. One, we can't avoid this one: cultural change in a digital world. So that's day 1. Day 2, we're going to be looking at how we can unlock innovation through transforming industry. And we're going to be hearing from people talking about robotics and modern methods of construction and so forth. But that's really the tech piece. Day 1 is more the kind of the humanities piece. And I suppose back to day 3, then we're going to be focusing on people. And people are the key to success, and particularly the need for a more diverse industry. We've just announced our first 3 keynotes. Rebecca DiCicco, a digital node, also founder of Women in BIM. Thomas Bock, you cannot miss this guy. This is an unbelievable presenter. This person is probably the most proficient person in the world of construction robotics. He doesn't talk that often. He spoke at the recent honorary event for Chuck Eastman, and I literally had hair standing on my head. I didn't believe it was possible to do what he has done and what he's developing. Fully automated construction robots. This is the future. And Alan Water is coming back after being with us at CitA Tech Live. Again, he's really going to disrupt and give you people an insight into the future, and many, many more significant keynote speakers from across the world. Don't miss this one. This is going to be great. So presentation papers need to be coming in now. I think it's next Monday. Is that right?
Monday, yeah.
Yeah. And so we've got almost 60 plus presentations. So we'll have number of keynotes, highlight presentations, and obviously the papers. We've even got one about, you know, using BIM for monitoring, you know, remote lighthouses. How cool is that? So it's going to be great. So, you know, so you need to be there. Don't miss this event. We rely on this also always at the end of the year. It's been a tough year for everyone. I won't lie if I didn't say that, you know, that CitA has done well with a great team, but we need to finish the year strongly. So we'd love the industry to support us, as we believe, you know, we are the voice of the industry in Ireland, and when it comes to digital construction, so your support would be greatly appreciated. So I think we have another slide, have we? Yeah, so just to thank our presenters today. This is, I suppose, a journey looking at these top 10 technologies. We're coming back, yes, on the 8th of July with looking at digital transformation of the Irish construction supply chain. So we're going to be hearing from Chadwicks, who are going to talk about the challenges and how the external forces are impacting on the supply chain and construction. You try and get concrete, steel, anything at the moment, timber, the cost has gone through the roof. But also they're transforming their businesses. So you'll be buying things seamlessly online in the future. You'll probably be buying straight from the BIM model or the digital twin. This is the future. But also we'll be hearing from Dan O'Gorman. Many of you have come across him before. He's going to be speaking from, he's going to be giving an overview of the, I suppose, the challenges facing SMEs in particular. And, you know, this is one event that we hope you can attend on the 8th of July. So really, that's really where we want to leave it, to thank everyone, to thank Simon and Natalia and Isaac for 3 really brilliant presentations. I thought they were excellent and very thought-provoking. To thank, I suppose, the CitA team, Suzanne, Shannon, Elenia, and Sam for all the hard work they do behind the scenes. And to you, our delegates, maybe a little bit down on numbers today, but wherever you are, you know, I wish you my best and enjoy the summer, and keep connected to CitA. Hopefully we'll see you at the gathering and back with us in July. Thank you.
Thanks so much, everyone. Thanks so much. It's great.
Thank you.
Bye.
Take care, everyone.
Thanks. Bye.
Stay in touch. Thank you.